going to talk about introduction to triangles. And the nice thing is it says general triangle information. Well, you've worked with triangles before, at least I think you have. And a triangle is a three-sided polygon. So again here, poly means many. So in this case, many is the 3, or the poly. And we indicate that something is a triangle by writing a triangle in front of it, and then we can say triangle ABC. The sides of a triangle are segments. So what we have in this one is we have a segment AB with a line over it. Remember, that's how we indicate segment. We also have a side BC with the line over it. And the third side here is AC. The vertices of our triangle are A and B and C. And at these vertices, it forms an angle, angle A, angle B, angle C. There's two ways to classify triangles. One way is by their angles, and the other is by their sides. All triangles have at least 2 acute angles, but the third angle is used to classify the triangle. So remember, we need to know acute, and I put them in the notes there. But a triangle where all 3 angles are acute is called an acute triangle. But all 3 of the angles need to be less than 90 degrees. And remember, we classify the triangle by the third side. So the triangle with one obtuse angle, again, the word for obtuse, or the definition of obtuse, is more than 90 but less than 180. And you can probably guess, based on what we just saw, that this is going to be called an obtuse triangle. And it follows along for our right angle. A triangle where there's one right angle means that we have a right triangle. And those are the triangles the ways that we name them based on the angles. And now we can also, well, almost here, one more here. An acute triangle with all angles congruent is called equal angular. EQUIL ANGULAR. EQUIL ANGULAR. And there we go. There's based on the angles. And now we'll get into the sides. An acute triangle. So all 3 angles are acute. If an acute triangle, third time's a charm, an acute triangle with all 3 sides congruent, they all have the same measure. This one's called equilateral. EQUIL A-T-E-R-A-L. A triangle with no sides congruent. So we have all, we have none. It's called scalene. Scalene triangle. And finally, a triangle with at least two sides congruent. And the key words in that sentence are at least. But if it has at least two sides congruent, it's isosceles. And all of a sudden, I'm thinking I spelled that word wrong. I-S-O-S. I did. Try one more time for the spelling. I-S-O-S-C-E-L-E-S. I-S-O-S-C-E-L-E-S. So the thing is, if something is equilateral, it has all sides congruent, then it's also isosceles because a triangle has at least two sides congruent. And again, we're going to identify triangles based on their angles and based on their sides. So let's look at an illustration of that, an example of that. If we look at these first two, classify the following triangles by their sides and their angles. And it doesn't matter to me if you put the angle terminology first and the side second, or vice versa. Just one way to name it based on the angles, one way to name it based on the sides. So remember, the tick marks here means that those lengths are equal. So just to help out on the video here, this length and this length, in fact those are the sides, two sides of the triangle are equal. And that's the word that we were just talking about a moment ago, which is the isosceles. But not only do we want to name it based on sides, we want to name it based on angles. And we see that box in the corner, and that box in the corner means that we're dealing with a right triangle. As we look at letter B here, what I first of all notice is one tick mark here, and then two tick marks on this leg, and three tick marks on that leg. So based on sides, what we can say is, because those are all different amounts of marks, this is a scalene triangle. There's the classification based on sides. And then we get into the angle. Well, 110 degrees is more than 90, but less than 180. So this is an obtuse scalene triangle. If we look at number 3, based on sides, we've got 4 feet, 4 feet, 4 feet. All of the sides are the same length. That is our equilateral. Based on sides, equilateral. Based on angles, well, we're going to have an acute triangle. Just as a little bit of an extra, because all three sides are the same, that means that all three angles are the same. So this is also equal angular. Get my L in there. And as we glance at letter D here, based on the sides, we've got 3, 4.8, and 4.8. We have at least 2 sides equal. That's our isosceles. And then in terms of our angles, 72, 72, 36, all three of those angles are less than 90 degrees. That puts us with the acute. So again, if we know the vocabulary, and I'm close to finishing writing the first test, there's going to be vocabulary on it. I've got some vocabulary in the review packet as well. But here comes some more vocabulary as we turn our paper over. Perpendicular bisector is a line, a segment, or a ray that passes through the midpoint of a side and is perpendicular to that side. If we look over here at the picture, here's a perpendicular bisector. And where it's passing through the midpoint is at that point right there. There's the box. It hits at 90 degrees. That's the perpendicular part, right angle. And it passes through the midpoint, which means that this length is the same as that length. For the video purposes, this length is the same as that length. We actually have 2 more perpendicular bisectors on here. This line here is a perpendicular bisector. Again, notice the box. That means that this is a midpoint, and this side is the same length as that. And it's the same with that third line in that triangle, which I won't graffiti up too much anymore. An angle bisector. Well, an angle bisector is a ray that divides an angle into 2 congruent angles. And I'm wondering here if I should have equal there. I'm going to stick with what I've got. But here's our ray. I've got an end point and an arrow. There's our ray. And what happens is that this length of that angle, or the size of that angle, is equal to the size of that one. And I'm going to erase to try to draw it a little bit better. Again, there's our ray. This length, that size, and this size. Divides it into 2 equals. Same thing if you look at the 2 hash marks over here in that corner. If we look at that. Then here, we get 2 there and 2 there. This ray divides the angle into 2 equal parts. Same thing with the third. median. I remember median because I like alliteration. So alliteration means that it it rolls right off the tongue. Median, middle, they go together. But a median is a segment whose endpoints are a vertex of a triangle and the midpoint of the side opposite the vertex. So looking at this picture over here to the right, a median has an endpoint at a vertex and the midpoint of the side opposite. So here's the segment, vertex to the left, midpoint to the right in this case, and notice the midpoint. So that means that this length here is the same as that length there. And the other two values here, the other two line segments, are also medians. Vertex, midpoint of the other side. This length is the same as this length. And then altitude, a segment that you draw from the vertex of the triangle, that is perpendicular to the other side. It doesn't hit at a midpoint, it just forms that right angle. So when we start here, it just forms a right angle there. No dividing it up equally. That's what the altitude is. And I'm hoping that as we work along, that somebody will come up with a little technique that can help us remember that altitude only hits perpendicular. There's no midpoint involved like it was on these other words. So let's finish by looking at a couple of examples here. And it says, determine whether segment AB is a perpendicular bisector, an angle bisector, a median, or an altitude. So what we're looking at in particular, when we look at this first value here, we're looking at this segment, and it hits at a right angle. But the thing is, this length is 3, and this length is 3.2. So is it a perpendicular bisector, an angle bisector, a median, or an altitude? And hopefully, as you're writing this down, because 3 and 3.2 aren't equal, this one's an altitude. If we look at letter B, we're looking at this particular segment. And on this particular segment, we start at the vertex, we hit at the midpoint of the other side. The reason that I know we hit at the midpoint of the other side is because we have one tick mark here and one tick mark here. And the nice thing is you can look on your paper and you can go, it's a segment whose endpoints are at a vertex of a triangle and the midpoint of the opposite side. Well, that definition is median. If we look over here at letter C, we're still looking in particular at the segment here. But now what's marked in our triangle is we've got a tick mark there and a tick mark there. Again, the nice part is for you, you can look up at this one, and this one says a ray that divides an angle into two congruent angles. So we don't know anything about sides, but we know something about the angle, and that's what makes this problem an angle bisector. So now that we've really spent most of our time doing words, let's put a little algebra into it. So in triangle PRS, PT is an altitude. Again, we go back up and we look at altitude. Altitude is a segment from a vertex of a triangle that is perpendicular to the line containing the opposite side. So PT is a right angle right there, or hits at a right angle. PX is a median, middle. So that means that this length here is equal to that length there. And if we know the words behind it, then we can solve this problem. And we want to figure out, it says find the length of RS if RX, so the left-hand yellow mark, RX is x plus 7, and SX is 3x minus 11. But because we know that we're at x, at point x is the midpoint, we can take 3x minus 11 and set it equal to x plus 7. Solve it the way your Algebra 1 teacher taught you. I'm going to move my letter to the left. There's the alliteration again. 3x minus 1x is 2x minus 11 equals 7. So we're going to move the 11 over to the other side. We get 2x equals 18. And then we can divide both sides by 2. So we get x equals 9. But remember, what we want to do is we want to find the measure of RS. So if we find RX or SX, it doesn't make any difference, but RX is x plus 7, we can take the value that we just found of 9, and we can put that in there. We get 9 plus 7 equals 16. And then what we know is that SX is also 16. So RX equals 16, SX equals 16. And again, find RS, that's the whole length, and 16 plus 16 is 32. Same picture, some different information. I want to find RT this time. And what we know is the measure of angle PTR, or we want to find RT and the measure of angle PTR. If RT is x minus 6, so RT this time is x minus 6, and angle PTR is 5x plus 40. But how big is angle PTR? It's 90. We've got that box in the corner. So measure of angle PTR is 90. And then we can take the 5x plus 40. I'm going to solve. Again, solve it the way your Algebra 1 teacher taught you. I'm going to subtract 40 from both sides. That's fine. We want to isolate the variable. We get 5x equals 50. And then 5 times x. We're going to undo the multiplication by division. And 50 divided by 5 is 10. Now, that's good. We need to know what x equals. because we want to find the measure of RT. So RT is given to us that it's x minus 6. And we're going to take this value of x, put it in 10 minus 6. So RT equals 4. And we also want to figure out what's the measure of angle PTR. Well, we didn't even really need to necessarily do all that work, if I remember correctly, because PTR is 90 degrees. It was a right angle that was given to us based on the fact that PT is was an altitude to the triangle.